Good afternoon, ladies and gentlemen. I welcome you back to the sessions in the suite of level 4 on complex number mathematics as our first topic according to information I have given before. I will be elaborating on complex number which was done on the 25th of February this year by Mr. B. Mukwawa, one of our members in LISA. He did elaborate profoundly all the necessary objectives as from where the complex number starts from. That the square root of a negative number does not exist in real numbers. Repeating what he did would be spoiling the broth. So I would continue from what he splendidly explained. So at level 4, the system is the same. A student is now comfortable because they're just less than 6 months to write. So they are ready to go. Besides, at level 3, some of the students are actually leaving the college or going back to start again. Because a lot of students, it's like a bottleneck. Students sometimes fail at level 3. So they have to do it for the second chance. But anyway, what they have to face when they get to this information of complex number is nothing else but continuation of what Mr. Mukwa talked about. For instance, in performing addition, subtraction, multiplication, and division of complex numbers in standard form. He did actually mention that in a way. If you go back to his videos on the 25th, you enjoy his session. I really enjoyed it also. Secondly, we would know how to perform addition, division on complex numbers on polar form. These are the only two applications which were done as polar form, division and multiplication. The only difference comes when we are dealing with squaring a complex number. That's when we seek the assistance of this gentleman, de Moivre's theorem. Only what he states is that if a complex number is raised to power n, your modulus should also be multiplied to the power n. That is r at power n, and your argument is going to be multiplied by n as a coefficient. So it is very simple in that aspect. Once you say z to the power 2, it is going to r squared cis, or use the mechanical method he talked about. There are 3 methods of representing complex numbers. So at this level, it is very interesting only to remember. They put a lot of application, division, subtraction, and all sorts of things, including multiplication of various complex numbers. In this instance, it's very interesting. Students, it becomes easier because it's a matter of polishing up, because the rest of the work would have been done on level 3 in terms of this practical work. If we did very well and comprehended with profound assimilation, then there would be no need to struggle. He can flow on his own now. As for swimming, I would just let them go. I would tell them you can fly like birds, because I would have already verified their capability, their assimilation, independently or as a group. So the Moivre's theorem is very interested in that aspect. Now, the only thing which makes these particular complex numbers getting into one's nerves if they are not ready is when they are talking of the intra-mathematic problems. some of them. The intramathematic problems, the ones I'm talking, when divide, multiply complex number in polar form, or you can be asked to change rectangular form to polar form, then it's squared, or whatever the examiner wants. So they are capable of doing that. That's intramathematics. But sometimes if you're given a story whereby you need to do two variables, equating those two variables, z1 and z2, and perform the operation whichever the examiner asks you, that's when it comes a difficult situation. Because students, mainly English or maybe Spanish, whatever, they don't comprehend the essence of the question. But all in all, it will be very easy if a student understands the word problem. I call them extra mathematic problem, which is the word problem. Whatever they're doing every day. This is very interesting if we did come to confront such a situation in examination, where someone has to produce his own system of equations in complex number and solve them. That would be very, very good. Now, in practice, we shall deal with that. I will either work them on this book, then send them as pictures, or I could go on a board whereby I will show you or elaborate in video form. Practical, there are a lot of things. I will just say, for instance, each objective, I will choose examples whereby you can follow, or you can bring your own questions. That will be very interesting. From my videos, whatever you want to ask me, let's start from there. Because I can't be taking the lead. I can be taking the lead into the concepts, but it's up to you to work with us, so that we can produce something tangible. Then another problem would come on the fifth objective. I've talked of one, performing those applications in standard form, also those applications in polar form, two of them. The Moivre theorem to raise complex number to its powers, talked of intra and extra mathematic problems. The fifth one would be, I think by this time, if by winter they have not done this, it will be very, very unfortunate that there will be disadvantages, since they will be writing maybe their trial by September. So this should be done maybe by first semester or beginning of second semester. And so solving identical complex numbers in rectangular form is another problem. If z1 is equal to z2, we have to produce yet again system of equations and solve them using the Pythagoras theorem, substitution, elimination. Some can use graphs. In some institution internationally, they can use matrix. Depends on which level, which path you are taking at your particular country. We are just saying this is international information which we share. I'm not saying I will know everything, but I'm just saying mathematics is a language. Like you see on the couch with mathematics, we are discussing. We might not have enough time to talk when you do practical, because like independently done things in maths, you are silent. That's why I urge students to do their own work in their own, because in the exam you are alone. So at this level, I think it will be very crucial for them to identify and solve two complex numbers in rectangular form. Here they say in rectangular form. They can also ask you to find, but usually you have to change a polar form into rectangular so that you can equate the two. That will be the situation given in that instance. because I don't foresee it. If you are using modulus and arguments, how would you equate that one? So it is necessarily that's why they say the objective is to find identity in two rectangular form complex numbers. Okay, I think I would be very much interested. It would be very marvelous to deal with such situation on a practical basis. I will choose from the textbook I've done. I have past exams, also past solved questions. I will send pics here, pictures, so that you can have a look at whatever the questions I've been doing over the years and I've been asked. Last but not least of our objective at level 4 in terms of complex numbers would be looking at complex numbers to solve problems as insolvable or unsolvable using real numbers. You find out some problems do not have answers in real numbers, whether I use a quadratic formula or use completing of square. So many methods to find solution of trinomials or binomial, or quadratic equation instance. So you have to actually understand that info. So in this instance, that will be the end of that particular course at the tertiary level. A student can do it very well here. Here they mention that you use complex numbers to solve problems unsolvable using real numbers, either by factorization, I've said that, or the formula, the quadratic formula. Some I have mentioned the matrix. It's up to you to use those inputs. So this is all I have for theoretical part for the 3 levels in terms of mathematics. We discussed at level 2 mathematics, numbers. We did talk about so many things. I think you have to visit the videos done on those particular days from numbers at level 2 to complex numbers at level 3, and there are different objectives. And now this is the end of the first topic. We shall be meeting each other when we progress with 4 other topics in theory as well as in practice. I thank you so much. Good evening and bye everyone. Thank you.